Okay, so here's the problem for Chapter 5. It says solar panels are becoming a heavily used source of electricity. Assuming the specific heat of the panels is 0.74, what amount of heat is absorbed by 78 kilograms of the panels if their temperature is increased by 17 degrees Celsius? And part B is what temperature change would the panels have if they emitted 520 kilojoules of heat? So for these types of problems, it's a calorimetric, I can't say that word, type problem. So that's going to be Q equals the mass times the specific heat times the change in temperature, delta T. So for this problem, you're given the mass. For the first part, you're given the mass, you're given the specific heat, and you're also given the change in temperature. So what you're looking for is the heat emitted. So you're given the specific heat in grams, so you have to convert your mass to grams. 78 times 1,000 grams over 1 kilogram. You get 78,000 grams. Just plug it into the equation. You get 78,000 times 0.74 times 17K, Kelvin. You end up with 9.8 times 10 to the 5th, just to keep it with the significant figures. And then that's your answer for part 1, joules. Part B says what temperature change would the panels have if they emitted 520 kilojoules of heat. So in this problem, you're given the heat emitted, so what you're looking for is a change in temperature, so the delta T. Just the same as the last problem, you have to, because you're given the, you're in joules up in the top, you have to make it into joules, so 520 kilojoules times 1,000 joules over 1 kilojoule. It's 520,000 kilojoules, or joules, so that's your Q. You plug everything into your equation the same as last time. 520,000 equals 78,000 times 0.74 times delta T. So when you multiply 78,000 times 0.74, you end up with 57,720. Divide the 520 for each side by 57,720, and you end up with your delta T as 9.0 Kelvin. So the temperature decreases by 9 Kelvin if the panels emitted 520 kilojoules of heat.